For lesson 7's homework, we're going to work on simplifying square roots. So we want to write each expression in simplest radical form. So the square root is 60. So we know that's not a perfect square. We got to find the non-perfect square and the perfect square that multiply to give us 60. And the best way to do that, realistically, is to use our calculator tables. So if you look here, I put 60 divided by x in our calculator. That's the easiest way to do it, because then what you can do is you can bring up your table and look at all the combinations that multiply to give you 60. So 1 and 60 doesn't help. 1 times anything doesn't help in this piece. So we have 2 times 30, 3 times 20, 4 and 15, 5 and 12, 6 and 10. And then none of our decimals count. And then once you get 10 and 6, a repeating one in the other direction, you know you've gone through them all. The only one that involves a perfect square is here at 4 and 15. So our perfect square goes on the left, our non-perfect square goes on the right. Square root of 4 is 2, and then the 15 will just stay in its square root. And we want to remember, if there are multiple combinations with perfect squares, we want to pick the biggest perfect square, not the largest number, the largest perfect square. So for 54, our combination is 9 and 6. 9's our perfect square, so it goes on the left. Square root of 9 is 3, and the square root of 6 just stays. For 192, the biggest square root is going to be 64, so 64 and 3. Square root of 64 is 8, and the square root of 3 is going to stay. For 125, we're going to get 25 and 5. Square root of 25 is 5, and then the square root of 5 just stays. So now when they put a number out in front, we're still going to simplify the square root the same exact way. So 24 splits into square root 4 and square root 6, but we want to make sure we bring our 3 down with us. Square root of 4 is 2, square root of 6 stays. Now with our 3 out in front, we are going to multiply the two numbers out in front. So 3 times 2 gives us 6, and then we have a square root of 6 inside. For 252, we're going to have the square root of 36 and the square root of 7. We'll keep our 17 out in front. Square root of 36 is 6. We'll keep our square root 7, and we still have our 17. So now we're just going to do 17 times 6 in the calculator, and we get 102. Keep the square root 7. Now we're going to do a couple word problems. So rhombus ABCD has diagonals with length 6 and 12. So we need to remember that our diagonals in a rhombus not only are perpendicular, but they bisect each other. So we've got 6 and 6, and 3 and 3. If we want to find the perimeter, first thing we're going to do is start off by finding one of the sides. Pythagorean theorem, 3 squared plus 6 squared equals x squared. 3 squared is 9, 6 squared is 36. Add them together, we get 45. When we take the square root, we are not a perfect square, so it's going to split into 9 and 5, and that's going to give us one side of our rhombus at 3 square root 5. If we want to find the perimeter, we're going to take that, multiply it by 4. We are only multiplying the numbers that are outside the radical, so 4 times 3 is 12, and we end up with 12 square root 5 as our perimeter. For the last one, square SQUA has side lengths of 5. Determine the length of the diagonal. So as we make our square, SQUA, if all the sides are 5, we know when we form a diagonal, we end up with a right triangle. So if we want to find that, we're going to do Pythagorean theorem again. 5 squared plus 5 squared equals x squared. So we get 25 and 25. Add them together to get 50. We will square root both sides. 50 splits into 25 and 2. And we end up with 5 radical 2 as the answer for our diagonal.